Start now has the heading of Space Programs and Vision. שמי רון אדם, אני מנהל את המחלקה לארגונים בינלאומיים וסוכנויות מיוחדות במשרד החוץ. אני אחראי על מערכת האום, על הארגונים שפועלים במערכת האום.
I'm the director of the Department for International Organizations and Specialized Agency at the Israeli Ministry of Foreign Affairs. One of those organizations is the UN Space Agency and the Space Program Department of the UN, which is located in Vienna. And the last speaker on this session is actually the director of that office, the United Nations Office for Outer Space Affairs.
There are many aspects of political aspects of space, of the use of space for the peaceful use of space, of course. The space is used for sustainable development. They are talking a lot now about new issues, the climate change. It helps prevent disasters. This issue is becoming a very permanent and very important issue in the use of space. They talk about long-term program activities in space technology initiatives, human space technology, etc. The issue was dealt for many, many years by the General Assembly. And every year the General Assembly, through the political commission, the fourth political committee, permanent political committee of the General Assembly, has every year adopt a resolution on this issue. This year the resolution was adopted few weeks ago, in 18 December 2012, and it talks about many issues that are dealt with in space. For example, this year, one of the paragraphs mentioned that it is essential that states pay more attention to the problem of collisions of space objects, including those with nuclear power resources, with space debris and other aspects of space debris. This resolution of the General Assembly calls for further research, for monitoring, and calls for international cooperation that is needed to expand appropriate and affordable strategies to minimize the impact of space debris on future space missions. Zeno said this is an issue which is very important, and the UN talks about the politics of South and North, and this is what we in the Foreign Ministry bring with us, and me as a director for international organizations, the issue of helping, assisting developing countries. This is why we are here. And one of the issues that is dealt in the General Assembly on this issue is, for example, the regional centers for space, science and technology education. One of them in French and English is located in Morocco, another one in Nigeria. There is a center for space science and technology education in Asia, which is located in India. And recently, and the General Assembly welcomed this year, the establishment in 2012 of a Center for Space Science and Technology Education for Western Asia, which means the Arab countries, and this is affiliated with the UN and is located in Jordan. So things are going on, things are happening also here in Israel, and I'm very pleased that we are moving on this issue, and we can contribute a lot, and we might join a committee, which we will talk about later on in this session. I would like first to invite Dr. Edganit Paikovsky. She's a space consultant at the National Council for Research and Development. Dr. Paikovsky is a fellow at the Yuval Ne'eman Workshop for Science, Technology and Security, and a lecturer at the Security Studies Program at Tel Aviv University. Dr. Paikovsky's fields of interest are space policy, international relations, strategic studies, and S&T policy. She completed her PhD dissertation in political science at the Tel Aviv University in 2010. Before that, she was a pre-doc Guggenheim Fellow at the Smithsonian Institution Air and Space Museum. In 2006, she was visiting scholar at George Washington University Space Policy Institute. And she became a member of the Israeli presidential team for national space policy. So I'm very happy to welcome Dr. Paikovsky, who will review the major trends in space policy and security in 2012. Please, you have the floor.
Thank you. Boker Tov.
Good morning.
כמדי שנה
Like every year, we are presenting you with some reviews about developments in outer space. This morning, I would like to focus on issues to do with policy and security. If we look at government activities globally, then we can say that government expenditure on space has grown, even though its relative share out of all space expenditure has gone down. The expectation is that the space market will continue growing, its commercial side, but on the other hand, thanks to freezes and stalemate on the global economy, then governments will probably have to continue being trying to save money, and that's and as a result of this, we're going to see more effort indeed happening in the direction of space, however, by maximizing investments. When it comes to policy and strategy, space becomes prominent in the policy of many countries who see investment in space and being part of that medium as a means for showing their real potential and for their potential and real capabilities, and also symbolic of that. There's one country that we normally don't think about when talking about space, and that's Saudi Arabia. It doesn't usually make any headlines, however, it actually announced its program for the years coming up to 2025, during which it's going to launch its own satellites. It will be interesting to follow. The budgetary constraint that I've just described means that a lot of thought is necessary when it comes to asking ourselves what is the direction the space agencies want to go in, choosing their coming missions, and this results in reassessment and reconsolidation of space programs in various countries. In recent years, up until recently, we have seen the moon. We saw the moon coming back, making new headlines, and there were many countries wanting to go there. But now there's been a change in this trend. Some countries have decided to stop those plans, and others switched over to Mars as their next goal or target. When it comes to security and sustainability in space, the idea is to secure safe access to space to everyone. And in this respect, I would like to divide what I'm going to say into three areas. First of all, debris. Second is denial of service, either intentionally or random. And third will be global efforts to reach best practices in space, better coordination. Throughout the year, there were many conferences and conventions which were discussing safety and security in space and sustainability as well. There was the DARPA conference last June. All this hype around this topic actually shows that there's increasing international recognition of the need to work together, act together, and see how we can make progress in that area. The issues of debris is nothing new, but it's become more of a focus of attention, and there are many attempts to try and cope with it. The attempts to cope occur in on various levels, starting from technology, diplomacy, and legal aspects. We see upgrading and reinforcement of monitoring systems which follow debris in space, trying to warn and prevent collisions. We get there are about 30 alerts per day over 72 hours span, which means that quite a few maneuvers occur ever so often, with countries changing the direction of their satellite in order to avoid collision. There is a lot going on concerning different techniques for cleaning up space. That's on the technical level now. On the diplomatic and legal level, there are all kinds of initiatives trying to determine rules of conduct, what to do and how to do it, in order for us to be able to operate neatly, cleanly, and safely in space. As for denial of service, this is an ongoing problem which keeps expanding for some time, quite a long time during this year. North Korea was jamming communication for South Korea. Iran is also jamming communication transmissions, and several reports were submitted this year about cyber attacks, such as a virus that penetrated the Japanese space agency's computers, as well as other similar problems, and they all need tackling. As for best practices and coordination, the higher the number of players in nations present in space, or other organizations present in space, there's more need for coordination. But and this is being worked on. However, the gaps are still big when it comes to different concepts. For example, there's the question of code of conduct for space behavior that the European Union initiated and is trying to promote, but there is still a difference of opinions on that. And there have been quite a few meetings and discussions of it recently, and last June there was a new version that was published. The first draft was published in 2008, and then in 2010 there was another draft. Last June a new draft was published of this new code, which already reflects a certain process undergone by the international community, but still the gaps are still very wide. There was a certain feeling that this code might gain some clout. However, right now it seems that people are more wary than, and this overwhelms the need to actually devise some rules. And it's not so certain whether it will come into any kind of fruition anytime soon. The renewed presidency of President Obama means that his line concerning his attitude towards space will continue, which means focusing the space program of the United States, trying to maximize investments with the help of the private sector. The economic crisis caused a lot of uncertainty, and many research institutes and other stakeholders in the US have published reports recommending a new strategy for NASA. For example, the NRC wrote in their report that in order to secure the international leadership of the US in space, it must formulate a stable and sturdy space program so that other nations would like to join it. Last year we have seen two other occurrences that bring together commercial and governmental activity around space in the US. The first being the reform on the limitations on export, which affects the ability to export space services, and the success of export, which actually supports partnership with the private sector. When it comes to military space, the US is still the leader in the number of satellites and the scope of activity, but the crisis is showing there as well, and that has an impact on the space industry in the US as well, because most of the budgets were designated for security and defense issues. In October, new targets and objectives were defined for space activity, among them the need for strengthening stability in that area, securing access to space, strengthening the industrial foundation, and fostering international cooperation. I would also like to emphasize that there is an increasing interface between security and space, and it has many manifestations in force build-up as well. In Russia, the crisis in the space industry is showing some effects, and it is perceived as a blow to the prestige of the Russian industry, and therefore the government has started supporting them even more, giving them more budgets. That's the reason why Russia is one of the only countries which actually during this crisis is increasing its space budget. As for the future, this year Russia published a plan for the coming 7 years, which is intended to preserve its capabilities of defense and to provide greater involvement and leadership, and it also includes a manned mission to the moon. In Europe, a year ago in February, the Vega was launched after 9 years of development, and this launch strengthens Europe's position and status and broadens its capabilities, but also supports the European policy for maintaining their own access to space. The European Space Agency, ESA, has grown, adding Poland to its ranks, and recently there was a meeting of the member countries in which they discussed the outline of their activity for the next few years. Yesterday we could hear directly from the head of ESA about this, meeting, and it's a kind of political declaration trying to strengthen the position of ESA and win some more budgets. But among other things, they highlighted the important things such as maintaining their own independent access to space and investing some 4 billion euro in different scientific programs. Side by side with the joint activity of European countries, there are quite a few countries who have their own national initiatives where we can see some progress as well. Britain, for example, continues a line that they continues what they started several years ago, strengthening their space sector, putting more budgets into it, and having a clear policy of operating in that area. China has shown its intention to send a satellite into send a mission into space in the coming years, and it is trying to reach some agreements concerning space debris and norms for behavior in space. China continues making progress with its navigation satellites. It sent a few more satellites to the Baidu system, which is the counterpart of the GPS system, and by the end of the decade they will probably be globally operational. Towards the end of 2012, there were some rumors that China is about to hold another experiment with anti-satellite weapons. However, the Chinese administration denied those rumors, and until now we haven't heard anything more. Looking at other players on this field, just a quick review. India said that it intended to have 10 launches this year It also announced that it was not going to send a manned mission to the moon, as was their intention originally. You must have all heard about the successful North Korean launch to space. We know that the satellite did reach space, but it's not active. On the other hand, South Korea put off several times their launch that they were going to do independently. But probably this launch will indeed take place sometime soon. Japan is increasing its activity in space. It said that it was going to launch an intelligence satellite sometime soon, this coming year. And coming back to our neighborhood, Iran is making quick progress in its own space program. You must have all heard about the poor monkey that was launched, who was launched this week, but they're also building a new space center and a new launching center, and Iran keeps making the same declaration, saying that it intends to launch a man into space by the end of the decade. And let me just take one last example, and that's Canada, which still sees space as a national goal, and it said that this year it's going to devise a space policy. But on the other hand, the Canadian space program has suffered some budgetary cuts, just like any other area in Canada as well. However, Canada still decided to make some progress with its radar satellites watching the northern pole, and this is going to be upgraded in the coming years. So that's what I had to tell you, and if you have any questions, I'll be happy to answer.
Are there any questions?
Okay.
They launched today.
So we heard the recent news about the politics and vision of space programs of different countries around the world. Very interesting. And just, do we need the computer? Yes? Okay. I'm very, very honored to invite our next speaker. Probably there is no astronaut here in the room, although we speak about space, except our next speaker, Dr. Satoshi Furukawa. He was born in 1964 in Yokohama, Japan. He received a Doctor of Medicine in 1989 and Doctor of Philosophy degree in Medical Science in 2000 from the University of Tokyo. Dr. Furukawa was selected by the National Space Development Agency of Japan as one of three Japanese astronaut candidates for the International Space Station, the ISS. Later on, he was dispatched to the NASA's Johnson Space Center, and it was in June 2004, to be certified as a mission specialist. He went through training, basic training, and at the JSC for about a year and 8 months, and was qualified for flight assignments abroad, a space shuttle, as an MS, the mission specialist, in February 2006. Dr. Satoshi was assigned as flight engineer to the International Space Station long duration mission, and he took off finally with the Soyuz TMA-02M along with Sergei Volkov and Michael Fossum on June 7th, 2011, and landed safely, thank God, 168 days later on 21st November 2011. So again, I'm very honored to call for our next speaker, who will bring us a bit higher than was the first presentation, higher and the mission and vision in space, a view from Japan. Thank you.
Thank you, Mr. Chairman. Ladies and gentlemen, first I'd like you to take a look at a short video clip. I filmed it from onboard the space station using a super sensitive high definition video camera developed by a Japanese company, NHK. And actually, Dr. Yoav Yair and his team worked with Ilan in SDS-107 to film the sprites from space. And sprites is, in short, gigantic light column, 10 kilometers in width and 50 kilometers in height. And this time, we, together with Dr. Yair and his team, worked as a team, and they provided JAXA and me weather forecast, when and where we expect lightning and sprites. And owing to them, I was able to film the video clips. So, and Dr. Yair is in this auditorium, right? Yes, Dr. Yair. We're most grateful to you and the team. Thank you very much. Okay. Here comes a video. Sea of Japan side, using Tokyo on the right side. And in the center of an area greatly affected by the big earthquake. This is the northern island of Japan, Hokkaido Island. Here comes the sunset. And these are noctilucent clouds at a very high altitude, about 80 kilometers. Here are lightning and sprites.
肉眼で見るよりも超高感度カメラの画面の方がずっと綺麗。右端に北米の明かりが見えてきました。その広い範囲に見えてる幻想的な緑のオーロラ。
This is 5 to 10 times faster than the real speed. Here are shooting stars. Please feel free to make your wish. Okay, thank you, and back. Okay, next comes PowerPoint presentation, and I'd like to talk about Japan Aerospace Exploration Agency, JAXA's space activities today. And here is an outline. First, I'd like to talk about JAXA's mission, then launch vehicles and satellites, then International Space Station and Japanese Experiment Module, and HTV, which is an unmanned cargo vehicle. Then JAXA astronauts and activities in Japanese Experiment Module. This slide shows JAXA's mission. First, to contribute toward a secure and prosperous society. Second, to expand human frontiers. And third, to develop advanced technologies. Let's look at these three objectives of JAXA mission with some examples. First, criteria. Contribute toward a secure and prosperous society are Earth observation satellites and communication and navigation satellites. Second category, International Space Station program, space science and space exploration. Third one, space transportation, basic technology research, and aeronautics. Let me briefly talk about JAXA budget. This is the fiscal year 2012 fiscal year budget, 172 billion yen, which is approximately $2 billion. And JAXA budget is gradually decreasing year by year, unfortunately. Okay, here comes JAXA launch vehicles. We have H2A and B and Epsilon rockets. H2A's first launch was in 2001. And 21 out of 22 successful launches. It has GTO 4 to 6 ton class capability, 4 tons with 2 solid rocket boosters, and 6 tons with 4. H2B is an augmented type of H2A. Its first launch was 2009, and 3 out of 3 successful launches of HTV, which weighs 16.5 tons, and to the ISS, and the GTO 8-ton capability. And the Epsilon rocket is under development, and its first launch is scheduled for this summer. And it's a 3-stage solid rocket. And here are JAXA operating in planned satellites and missions. And the purple line indicates, on the right side, the land observing satellites. And the green line in the middle indicates the comm and navigation satellites. Let me talk about the middle one. Kiku 8, after the gigantic earthquake disaster in 2011, it supported those affected in the area to keep comm capability, because after the disaster, the ground-based station became inoperative because of the damage to the stations. And on the left side, blue line indicates the global observing satellites. The Shizuku GCOM-1 observes water circulation, and GPM DPR is a joint mission with NASA. JAXA is responsible for radar. And EarthCare CPR, it's a joint mission with ESA. And JAXA is responsible for radar again. And next. Here comes JAXA space science missions. It includes astronomical observations and solar system explorations. And on the right side, Astro-H its launch is scheduled for next year. And it's a new generation X-ray observation satellite. Spica is a next generation infrared observation satellite. On the lower side, as Neely discussed, Bepi Colombo is a joint mission with ESA, JAXA, and Israel, and to explore Mercury. And its it is targeted to be launched in 2014. Selene 2 explores the moon, and Hayabusa 2 explores a C-type asteroid to explore the origin of the solar system. Okay, let's move on to International Space Station. This is the International Space Station, and here is Japanese experiment module. Nicknamed Kibo, that means hope. It consists of pressurized bus-sized pressurized module and pressurized storage module and exposed facility, as well as robot arm and airlock. This is a picture of the pressurized module and pressurized storage module and robotic arm. Another picture of Japanese experiment module with the exposed facility. This is the internal view of Kibo. Look at him. Koichi is upside down, but it doesn't matter under zero gravity. And he's vacuum cleaning the module. And this is a view from a window of the Kibo. And this is a photo from the mission control room for Kibo in Japan. It works 24/7 with 3 shifts. This is the Kibo mission control team. And these talented and hardworking people are assets to Japan. Okay, let me move on to HTV, H2 transfer vehicle, which is an unmanned cargo vehicle. It is launched by H2B rocket from Tanegashima Space Center in Japan and rendezvous to space station, then grappled by a space station robotic arm made by Canada. And it has pressurized and unpressurized cargo and can deliver a total of 6 tons of cargo. And let me talk about HTV Rendezvous. It approaches to space station Nader, 10-meter distance, several days after launch. And it stops relatively to space station. Then crew captures it using space station robotic arm. And remember, both the space station and HTV are flying at a speed of 8 kilometers per second. So there's a risk of potential collision. So, ground staff watching and praying. Then, capture confirmed. So, a storm of applause and handshakes. This is the HTV team, Konotori team. It's nicknamed Konotori, which means stork in English. These people are also assets to Japan. Now, I'd like to talk about JAXA astronauts. We have 8 JAXA astronauts, active JAXA astronauts, 3 engineers, 2 pilots, and 3 medical doctors. 3 engineers are Aki Hoshide, who stayed on board the station last year, lower left, and Koichi Wakata, who is going to have 4th space flight this year, and Soichi Noguchi, who is the current chief of the JAXA astronaut office. In the pilots are, upper left, Takuya Onishi, who was an ANA commercial pilot, and Kimiya Yui, who was a pilot in the Japanese Self-Defense Party. 3 medical doctors are Chiaki Mukai, Norishige Kanai, and me. This slide shows the HTV launch schedule and JAXA astronaut activity. We had 3 HTV launches and 4 launches in the future. And we had 4 long-duration flights. Koichi Wakata, Soichi Noguchi, me, and Aki Hoshide. And Naoko Yamazaki visited the space station in a space shuttle mission in 2010. And at the end of this year, Koichi Wakata is going to have his 2nd long-duration flight to the space station, and he's going to be that first Japanese commander of the space station in the latter half of his mission. And Kimiya Yui is going to have his long-duration mission, first flight, in 2015. And 2 young guys are under training, aiming at future ISS mission. Okay, I'd like to talk about activities in Kibo. For life sciences, physical sciences, human research, space Earth observation, technology, and education and art. This slide shows life science experiments in Kibo. Cell biology, radiation effects, plant, microbiology, and so on. This is a very busy slide, so let me talk about one example, which is C-spins. Auxin is a hormone, plant hormone. It plays an important role in plant growth and reactions to gravity. So, in order to investigate the effect of auxin in space, cucumber seeds were used. We incubated it for 24 hours and harvested. We wish we would be able to have fresh salad, but we did not. And it's in the evaluation process right now, and it can lead to development of new tools, methods for plant cultivation in space. And this slide shows physical science experiments in Kibo. And let me talk about one example, which is a high-quality protein crystallization experiment. In space, zero gravity, very good quality crystals can be made. And it cannot be done on Earth because on the ground, the crystals get distorted due to its own weight. And after bringing back the good quality crystal samples to the ground, by using X-ray diffraction technique, very detailed 3D structure can be determined. And there's an active site in a protein. It's like a keyhole. And by determining the 3D detailed structure of the keyhole, we can easily find a key which fits very well in the keyhole. And the key indicates a new drug or medicine. And it can contribute to drug creation for muscle dystrophy, influenza, and so on. And proteins that dissolve cellulose can make biofuel from non-food, because if we can dissolve cellulose industrially, we can make ethanol from chips of wood. Here are some examples of human research: ECG, hair, microsample, and so on. And this is another example of human research. In short, using commercially available devices, we made an onboard system to manage the medical data of astronauts. And data can be monitored by both the crews on the space station and staff on the ground. And I made constructive suggestions to make it better. Okay, here's an example of a space observation experiment. Excuse me. MAXI is an outside payload. It observed for the first time in the world a massive black hole swallowing a star located at the center of a galaxy 3.9 billion light years away. And it was accomplished in coordination with US satellite SWIFT and published in the prestigious journal Nature in August 2011. And here's an example of technology, small satellite deployment system. Instead of directly launching satellites, these 5 small satellites, 10 centimeters cubic, were launched in HTV and transferred to ISS, and then deployed from the space station in last year. And it provides better vibration during launch to satellites. Okay, here are some examples of education and art. Green tea, upper left. It had 2 objectives. One was how the green tea powder dissolves in water in zero gravity from fluid physics point of view. Second one was cultural. That explains why I was wearing this colorful, fancy costume. And lower left, spiral tops. It used an arm with positional and point light sources. and an astronaut spinned it like a top. And photos were taken using long exposure time. In the middle ink ball, I did it, and I put fluorescent paints to the surface of a water ball in zero gravity. And on the right side, try 0G, I'm blowing soap bubbles, checking if compass works in zero gravity. It actually worked well. And checking how a balloon behaves in 0G. And the lower one was checking cerebellum function. Believe it or not, I am not so good at this kind of cerebellum test even on the ground like this. If I close my eyes, I can't. I'm bad. All right, and this is a launch pad of H2A and H2B rocket on an island located at the very south of Japan. Thank you very much for your attention.
Thank you very much. It was really exciting and interesting to see what you saw from space and to share it with us. Thank you very much. קצת פרופורציות כמובן בשבילנו, מה שאפשר לעשות.
For what we can do, and we must always remember that we're not alone in the world, and we do need some modesty, and that we do have plans, and hopefully we will be able to get better. I don't suppose you have $2 billion, Menachem, but I hope that there's someone here from the Ministry of Finance who will hear what others are doing. As תודה רבה שוב. זה היה...
Our next speaker is Menachem Kidron. He is the Director General of the Israeli Space Agency. Menachem is a chemical engineer, and he worked many, many years, 35 years or more, in Rafael. First as a system engineer of solid rockets motors. He was director, propulsion systems, and Manor Directorate. He was executive vice president and director general of the Manor Technologies division, and then director general of Space Systems Directorate in Rafael. It says that he's dedicated, results-proven professional with over 39 years of documented success in science and technology. So I'm very, very pleased to invite Menachem Kidron, as I said, the Director General, and he will share with us the $2 billion program that they have in Israel. Thank you.
צהריים טובים לכולם.
Everyone.
ברוכים הבאים בכנס.
Welcome to this conference, welcome to this session. I was sitting here watching the pictures shown by astronauts for Furukawa and the Japanese space program, and I was very jealous. But one day we'll get there. So once again, good morning and hello. To begin with, I would like to thank a few organizations that worked with us, are working with us, will continue working with us, industries, space industry, leading space industries such as IAI, Elbit, ELOP, Rafael, of course, universities from all over the country, from north to south, and the Fisher Institute, smaller organizations, and various startups that we worked with, and all the others are probably somewhere in all kinds of places. They have to be pulled out of there. Thank you all very much. Thank you for helping me with this presentation, and thank you for the future activity that we will have together. Now, I wanted to present several things. First of all, I wanted to talk a little bit about the space program and how we got there, and especially focus on where we're heading, what we are about to do. We all know, and we have said more than once, that space program started several years ago when a team was appointed by the president, who is very much aware of issues to do with space, science in general and space in particular, and with the help of the Director General of the Science Ministry, Menachem, and the former head of the Israel Space Agency. They submitted a document that you can see here, recommending to the Israeli government a set of solutions, what to do, how to do it, what needs to be done in order to push forward the space field in Israel, what resources are needed in order to position Israel well in view of the existing risks. So a lot has been said already in this conference about the importance of space, so I can't add much, but I want to show you 3 slides. Space is a strategic resource. Obviously, there's no doubt about this. And I'm not only talking about the military side of it, I'm talking about everything to do with it. Space as a motivator and an engine which drives forward technology, research, pushing people in those directions, sparking imagination. It's really interesting. Such films as we saw right now from Japan really excite us all and develop the high-tech industry. We all remember what technology looked like before the first launches by the Russians and the Americans, either to space or to the moon. And definitely this platform brought forth many new technologies and promoted everyone, pushed everyone forward. And there was a special interest in taking that into space. It encourages the industries and researchers as well, and of course carries some benefits from the point of view of national security, etc. Now, when we looked into the matter, we found, not to our surprise, that in Israel, just like in many other space-leading countries, there are very distinct capabilities, very clear capabilities that have been developed over the years, especially when it comes to micro-satellites and things such as remote sensing, SAR, communication, and the academic world in Israel has a lot of knowledge. It's very well known around the world that our academic community is very advanced, and we've seen how many Nobel Prizes were received by Israeli scientists over the last 10 years, so we have the infrastructure and everything. But on the other hand, there are quite a few risks that we also presented, and eventually this program was showing what was necessary and where we want to get to. It was 70 pages. Of course, I'm not going to show you all of it. I'll just focus on the main 5 goals that we want to obtain. So here are the main objectives. At the very bottom, the very foundation, is our society and our students, pupils, the public at large, our entire community. And this is something that we must support and outreach and increase that. Everybody is doing it. We see it in NASA's programs and in ESA's program, JAXA as well in Japan. Everybody is going in that direction. It is very important in order to build the structure that we want to build. The second tier is to improve and expand the expertise, the skills, be it engineering skills, technological skills, either human know-how or technological capabilities, either in the industry or in the academic community. If we do that, we will be better equipped to continue. And when we continue, we want to create collaborations. Ganit has already said this is the direction the world is going in. Not only in space, everybody realizes by now that collaboration saves time and money and creates some contacts, and this is the direction where we want to go. Beyond that, one of our important objectives is to help our industry advance and make sure that it has such capabilities with technologies and products that will be very attractive and will increase their competitiveness around the world and in the civilian market as well. This is where the big money is, this is where the budgets are, and the more successful they are, the more profitable they will be, and the more they'll be able to invest in future generations, and this way we'll be able to reach our vision to bring Israel to a position of one of the five world leaders in space. We all hope that all this will be done. And when we took these goals, of course, this is just in a nutshell, we set up a whole plan, and the plan is based on understandings between the Israel Space Agency, the Ministry of Science and Technology, and the Ministry of the Treasury. We're talking about 500 million shekels, a lot less than was mentioned here before, but it's quite a bit of money, and we want to use it and try and implement this plan. It took us a long time to put together, but it's a living plan. It's alive and kicking. It's going to be updated annually and perhaps even biannually, because there are new ideas every time. They keep coming up. So this program is now, we now have a multi-year program, and this is its breakdown. We can see that it is divided into more or less the objectives that we wanted to obtain. The pie chart shows the resources which are going to go into each part of it. So international cooperation will take up some half of the budget, about half of the budget, and I'll soon explain why. Everything to do with R&D in space industries and getting it to be more competitive also takes or gets a large chunk of the whole pie, about 25%. Basic research, the academic research, etc., that's another thing. And there's a community in space and operations, which even when we try and keep them as small as possible, they're still there, and we have to be precise about them. Let me try and present this and give you just a few examples from every piece of this. In international cooperation, we intend to do those whether they result in new commercial corporations or in new academic corporations. We mentioned already our indented cooperation with NASA, with CNES, with ASI, ESA, and others. Cooperation is very important. Beyond the fact that we really have to promote these things and we want to save time and research, these ties between different industries around the world will help us flourish and speed forward even without our ongoing support. Just a few examples, some of them must have been mentioned already, so I'll try and speed up here. We have the Venus program in cooperation with CNES, the French space agency. We're talking about launching a satellite with 2 payloads, a technological one and a scientific one. It's a multi-spectral camera that will deal with environment, agriculture, and several other things. And another one which will be about electric propulsion in space. We're in advanced development stages. We intend to launch in 2014. There were all kinds of difficulties, some technological, some political, but right now we already found a launcher, and hopefully everything will be completed by 2014. The IAI has a major part in it. They are managing the project, and Rafael are also partners to it. These two industries are putting a lot of money into it. I can only estimate that now they're putting more into it than they did before. Here we see the two payloads, the camera on the right-hand side, which is developed under Knesset supervision, however, in Israel, in Rafael, and on the other side you see the electric propulsion. It's easy to see that the entire satellite is being built here in Israel with Knesset and the ISA are only leading it, and this is how we created a wonderful cooperation between the agencies, between the industries, and of course the people, which will probably result in some more cooperation in the future. One of the things that we see as a potential for further cooperation is to start developing electric propulsion systems for larger satellites. This is something that CNES is very interested in, and the ISA is also interested in something of higher wattage and things that will be able to hook up with larger systems and satellites. So this is another thing. Shalom is something that we also heard a lot about. This is a collaboration with the Italian Space Agency. We are already we are now at the feasibility study stage. This is a hyperspectral satellite, very challenging, very daring. It's not going to happen in a couple of years or so, and it's not that, and it's not inexpensive either. But the idea is to present the capability for spectral sensing from hyperspectral sensing from space, and if it works out, we will have to start looking for resources for full development and then launching, etc., etc. Probably many of us here know what hyperspectral means. We can see issues of soil mapping and classification, different crops, right down to the molecular level. Air pollution also down to the molecular level. And it's also possible to look for minerals, very attractive around the world these days, and we are really counting on this cooperation. Another topic which is also under competition, that's something quite still in the future, was an idea by the Weizmann Institute, which is to put up a satellite in space which will look into deep space, trying to identify star explosions, supernovas, and other such stuff, with a very wide angle, using UV sensors, with an intention to look around the very broad angle, and then when something is detected, direct better telescopes in that direction and get the information. We got together with NASA Ames, which is a very well-known center in NASA for R&D, and we are expecting an answer from them. We're also trying to find out a more attractive configuration as well as a cheaper one. And we're waiting. Definitely, this is a very attractive idea, and the world is taking an interest. This is more or less what we are talking about here. Hopefully, it will come true. Another thing that we're doing with ESA, we discussed several times, ESA. Here we're talking about micro satellites, also to do with electric propulsion, where the advantage, as you probably know, is the energetic utility that you can get 5 times better than that of ordinary propulsion. The thing is that it's low. It's only low power. So if you have enough time, then you can get things going all kinds of places. And the question is whether we can do it with microsatellites. I sat together with Jean-Jacques Dordain yesterday, and we decided that we're going to go ahead with this, developing microelectric propulsion. This is going to be done by Rafael and an Italian company, together with the Technion, the Usher Institute, and several other organizations. Another example for activity with ESA is the SCD, showing the feasibility of laser diodes in space. They've already shown it and they're supplying it to other companies, but this is something more daring. We're talking about the laser diode, which is going to be tested here as well, and especially in the national laboratory in Holland. Once it's approved, then ESA will give it a stamp of approval, and this would be very good for us to use in order to sell and start entering the market. These two things are being done, are being worked on right now. Here, I wanted to say one other thing. These are only examples. We have at least 15 or 20 other things that we're thinking of, and we're looking for some more. We're looking for more, and we're going to continue looking for them. Now, unrelated to this, we intend to sign cooperation agreements with other countries as well, either space agencies or other organizations such as the EU and others, or and we'd like to try and identify all kinds of topics that tie in with the mandate that we have to push forward when we have the right kind of interest. And we're talking about topics of interest which are very attractive to the commercial market, and if we come upon such ideas, then we will be very happy to put them into our list of plans. Now, when we're talking about R&D in space industries, here's a list of things that some of them are already being implemented and some not yet. As for communication, SATCOMs, we said already that we want to leverage 2 main capabilities, micro and nano satellites. That's one thing, and also SATCOMs. SATCOMs are something that we regard as a major platform for us to use in order to enter the world market. Undoubtedly, the IAI, who are the leaders in this, who are leading this area, together with other companies, need a few gems, I call them. And if we develop those, then we'll become a lot more attractive when the next competitions come along, GAMOS 7, 8, etc. And that's why we have to focus on these. Maybe the IAI will have to rely on the supply of critical components from companies that compete with it on the system level, and that's why we have to find out how we can actually do it and put some more thought into it and probably some more money. Some examples for things that can be integrated already is an onboard processor in space. We know that processors on Earth work faster, in space they work slower, and that results in all kinds of difficulties. There are all kinds of thoughts, for example, by Ramon Chips. Here's an example to take such processors which will be completely accommodated to space and will be able to function in the larger heights and distances, because we need to go further in the LEO and the GEO. The wattage should be very low, so it won't generate much heat. And all of the initial tests show that these are things that the company is actually able to provide. What are the applications? You can see it on the right-hand side here. And if this company indeed delivers, then they're going to be world leaders, except for the Americans, who are also in the same area, more or less. So you see the rates we're talking about, whereas in ESA they're talking about 2018. So this we're talking about a different pace here, and hopefully this will be successful. Something that is really new. We just learned about it recently. Another company called Satisfy, kind of a startup really. They produce communication cards. This is a ground station piece or element, but maybe it can be taken up into space, and that might improve communication 10 times. These are also ideas that we are looking further into. And another idea has to do with the nanosatellites. Nanosatellites for examining all sorts of things, testing all kinds of things, such as materials and coatings and structures. Here's an example. There's another one. So these are just 3 examples of the things that we have in mind. I can't say I'm pleased, I can't say I'm satisfied, not because these are not good, and not because cooperation with internationals isn't good, and not because we have chosen something which wasn't good, or that I don't think they'll be able to deliver, these companies. I'm not so happy because we are expecting to see many more ideas. This country, as we all well know, has a very strong streak of creativity in it. We have so many scientists here. Some of them are not even aware of the possibilities here. We'd like to see a lot more ideas. We would like us to have to decide between tens, if not hundreds of ideas. And I'd like to give you a take-home message here, that companies should come to us and present their ideas. Our door is always open, and we can always update our plans, even in the middle of the year. Our budgets, we will leave some budgets free for ideas that might be available later on. As for basic research, we have called for ideas. We've issued a call for ideas. We defined it as having to be around space topics. We want all kinds of ideas to do with gazing from space down to Earth, or the other way around. We are talking about different components, different technologies. Everything is open, and indeed we got quite a nice list of topics. We're now going through evaluation stages, and probably during by the end of the first quarter, we will have finished the process and have chosen the right topics and get them going. And towards the third quarter of the year, we're going to issue another call for ideas, and probably we'll get some other good ideas from the same areas, because it's the academic world which comes up with ideas, and then the industry takes them up. One thing that you may have heard about is called Samson. This is led by the Asher Institute for Space Research at the Technion. The idea is to send up 3 nano satellites and get them to fly in formation and communicate with each other from different distances, both short and long distances, and thus enable them to locate and identify. And these are important things. It's true that it's only nano, but if their capabilities are proven, then we can go into a larger model and then create some smarter constellations still. This is a very exciting idea, and many people around the world want to join in. The Asher Institute is leading this very nicely. The space industries are supporting it. Some support R&D, some help in other ways. IAI, Raphael, ELOP specialist, and other industries that I haven't included, unfortunately. But they're talking about launching this in 2015, and this is one other thing that we support now. We only joined in towards the end of last year. So this is part of our call for research or studies, and we're also talking about centers of knowledge. We want to locate centers of knowledge in this country that focus on various space-related topics. It could be in the industry or the universities or a mixture. And if we think that it's a good idea and then we're going to try and promote it, we have to maintain what there is, we have to preserve what there is, but also make sure that the infrastructure develops further, either the human infrastructure or the equipment and other kinds of infrastructure. Here's an institute which is in the Golan Heights, and it deals with cosmic rays. I don't know how many of you know this place. It's been there for several years and is managed by immigrants from the former Soviet Union. Really wonderful people who are working there and researching in all kinds of weather conditions, studying cosmic radiation, surveying it, and sending the data in order to alert from storms, etc. The next topic is that of community in space. So I have said already that the issue of space, society and community in space is something that we have taken to heart especially. One of my deputies deals specifically with education, society and community in relation to space, trying to give it special attention. And this special attention will be manifest in everything. One of the things that we do is supporting the Space IM program for landing a vehicle on the moon, a space vehicle on the moon. It gets a lot of hype, and hopefully they will eventually get the budgets necessary. It's just a handful of people who volunteered, not for profit. They only said that if they win the $15 million prize, they will invest it in space-related development in the community, society, etc. And I can only wish them success. Obviously, this is something that grips the imagination of everyone. Young people, engineers as well support this. And the industrial enterprises also support this. Another thing we said is that we really want to increase the awareness to the importance of space. That's the reason why we're holding a very special Space Week this week in museums and in other places with children building planets in the solar system, and some of us went to give lectures on space in bars and pubs in Herzliya and Tel Aviv, and we go to education center, different space centers, and just increase awareness of the public at large, and especially school pupils and students, and in the hope that they will grow into the next space generation. This year we also had some activity trying to bring the International Astronautic Foundation Congress to Israel, and a few months ago indeed we were successful, and the decision was made by that General Assembly that the international, the 66th astronautic exhibition will take place in Jerusalem, and I'm sure that all of you will attend, as well as another 4,000 people from the rest of the world. What do we have to do in the coming few years, in the near future? I just ran out of place, otherwise I would have written a lot more. We have to finish the Venus project and finish integration and get organized for the launching at the end of 2014. Shalom, we really want to meet the timetable and finish the feasibility study by June, then have meetings with ASSI, and then see if we are going to full-scale development or not, and also look for budget, which is not going to be easy, especially on such a difficult year, so many problems. But we are sure that the Ministry of Finance, who negotiated with us and agreed with us on a space program and understands it, will be open to us. Limsat, I've already said, we're waiting for an answer from NASA. First of all, that we actually won it, and secondly, to see how we can reach a solution that will be acceptable, especially financially acceptable. We want to push forward more cooperation with other agencies and organizations. There are some agreements which are about to be signed. We thought that we would sign some of them here in this conference, but it didn't come to pass. There's an agreement that we signed with NASA in 1996, and it has to be extended. We we planned some more activity with NASA this week, trying to see how we can sign this in a few weeks' time, and to see what else we can include in it. We want to expand the number of projects that, the R&D projects that we support. We want to finalize the list of projects for international cooperation and choose the right ones. We want to kick off those projects that came to us when we issued the call for ideas, and we want to be even more promotive of our ties with the community, and start dealing with the conference that I mentioned before. And there must be many other things that have to be done. And once again, I call on you all. The door is open. The email is there. Telephone, SMS, everything. Please call us in any way you wish, and we'll do our utmost to see what we can do to cooperate. Thank you very much.
Thank you very much, Menachem Kieran. Congratulations. Hope you'll be able to put it into effect, including the community education collaborations with the world. We have a lot to be proud of, and if we take it in proportions, the economy of Japan is about 12% of the world economy, and we're about 1/3 of the world, 1/3% of the world economy. So I think what you got is, אז למדנו על תוכנית מאוד מרשימה שיש לנו כאן בישראל, ודיברנו לפני כן עם דוקטור עות'מן על הצורך בשיתוף פעולה בינלאומי והחשיפה של הידע הישראלי בעולם, והמקום הנכון לעשות את זה האום, משום שכולם נמצאים שם, המדינות החברות נמצאות שם, ואחת הוועדות החשובות ביותר
use of outer space. This committee meets in Vienna, and there are 74 countries who are members of this committee. Israel is not yet a member, but we are planning very soon to join this committee. We see a tremendous change and upgrade of the Israeli space agency. We see budgets, we see new programs, and I think that it is about time we join this committee. Our next speaker and last speaker for this morning is Dr. Mazlan Othman. She's the director of the United Nations Office for Outer Space Affairs, which coordinates the work of this committee and other committees and subcommittees. Dr. Othman is a Malaysian. She has the PhD in astrophysics from University of Otago in New Zealand. She was seconded to the Prime Minister's Department of Malaysia in 1990 to head the Planetarium Division, which later on became the National Space Agency, where she was the Director General of the agency for many years. Before that and after that, she was appointed to head this Outer Space Affairs Division in Vienna in 1999, and then again she was appointed by Ban Ki-moon, reappointed to head this, the UN-USA in 2007. As an academic, she has published papers, numerous papers on space, environmental management issues, and national and international journals. And she has the hobbies. I'm not sure you are familiar with that, but it says that you have the hobbies of cycling, mountain climbing, trekking, and you have also amateur radio, which is very impressive. Thank you very much, Dr. Mazlan. Please come on and take the floor. The space and United Nations. Thank you.
Good afternoon, ladies and gentlemen, and thank you, Ron, for that introduction. I am pleased to present to you now to tell you how space figures in the United Nations system. My talk will consist of two parts. I'll first of all focus on the work of the United Nations Committee on the Peaceful Uses of Outer Space, and then I'll highlight the work of the Office for Outer Space Affairs. Now, this is a bit of a complicated picture. As you know, the United Nations system is a complicated system. I can't tell you how these things interconnect, but we are a huge organization. But the most important thing for you to note is that space actually transcends the entire system. So space-derived information is actually used in dealing with humanitarian affairs, with refugees, with peacekeeping, with atomic energy, with comprehensive test ban treaties, with drugs and crime, and of course with the Office for Outer Space Affairs. So in order to deal with the issues of space, the General Assembly, as early as 1958, which is a year after Sputnik was launched, established at that time an ad hoc committee on the peaceful uses of outer space in order to deal with international cooperation. Later on, in 1959, it mandated the ad hoc committee as a full committee, and in order to deal with issues of the exploration of outer space. And in 1961, the committee became a permanent committee and it met for the first time, which is why the committee celebrated its 50th anniversary last year, I mean in 2011. And at the same time, it established two other bodies, which are two subcommittees, one of dealing with scientific and technical issues, and the other on legal issues. Now, this committee reports to the fourth committee of the General Assembly, and this fourth committee is called Special Political and Decolonization Committee. I know it has nothing to do with space, but that was originally and historically where this first committee was formed. And every year, for instance, I go to New York and we present the report, and the General Assembly adopts a resolution on international cooperation in the peaceful uses of outer space. So let me talk a little bit more then about the work of the committee. Now, it is the only committee in the United Nations that deals with international cooperation in the peaceful uses of outer space. So it is a unique platform, a unique political and diplomatic platform. And you'll see what are its achievements in a minute. But COPOS, together with my office, the Office for Outer Space Affairs, managed to organize 3 major United Nations conferences on the exploration and peaceful uses of outer space. All of them were held in Vienna. The first was held in 1968, the second in 1982, and the third in 1999. And this series of conferences were called Unispace. I'd like to refer to the most recent one, which is the third conference, Unispace 3, where it was outlined a variety of actions. Most importantly, how to protect the global environment and manage our natural resources, and of course increase the use of space-derived information for human security, development and welfare. And today we mentioned space debris, and I'll talk about it a little bit more, is how to protect the space environment. And especially, and this is always a focus of the United Nations, is how to get the developing countries to benefit more from the use of space. So Ron mentioned COPOS many times, and the desire of Israel to become a member. To me, it is high time and for Israel to consider becoming a member. There are now 74 member states and 32 international organizations. I've listed here the various members in the different regional groupings. And Israel would come in that final grouping, which is Western European and other states, which include Australia, Austria, the United States, and others, and Japan as well there. The COPOS annual general meeting schedules are quite fixed. In February, in a few days, we will meet for 10 days. That the Scientific and Technical Subcommittee, and later in March, and sometimes going to April, the Legal Subcommittee meets, and then the main committee meets to adopt the resolutions of the 2 subcommittees, and of course it has its own agenda item as well. And I mentioned to you that in October I will attend the General Assembly in New York, and where the chairman of the committee, which is at the moment Japan, will present our report to the General Assembly. So here are the highlights of the work of the committee. It's been mentioned before, space debris mitigation, then to do with the safety framework in using nuclear power sources. So let me talk about some of the issues we are dealing with today. The first is about greening space. I know that when we talk about green space, we also talk about the systems that we use that are environmental friendly, but we are also talking about how to make the space environment more sustainable. And as you saw, space debris is always a difficult issue. Unfortunately, this problem doesn't go away, and in fact, this problem increases as time goes by. And fortunately for us, in 2007, the committee adopted space debris mitigation guidelines. But as you know, guideline is just a guideline, and it's not legally binding on any member state to abide by these guidelines. So we, I believe, still have a long way to go in solving space debris issue. The other interesting topic being pursued in COPOS is threats from objects from outer space, particularly near-Earth objects. So if you think about it, if we ever know that there is an object, there is a big rock from outer space that's going to fall onto Earth, and you know that there is a theory that it was an asteroid that caused the extinction of the dinosaurs. So this is a big issue because it could cause the extinction of humankind. Who shall address this issue? And if we have the capability to move the asteroid, where should it be moved? Who should move it, and who has the right to decide where it hits on Earth? So these are some of the issues that need to be resolved. And this year, the working group should be able to give us a recommendation what should happen. The other important development that's going on in the committee is about long-term sustainability on outer space activities. As you know, space applications such as Earth observation, communications, positioning and navigation, with their innumerable applications, they are so important for the way we deal with the issues, the challenges of our times, climate change and all that. But in order that we should continue to benefit from the presence of that space infrastructure, we must protect the space environment. And now this is a very important issue. So I mentioned to some people there are expert working groups. One is how to support sustainable development on Earth. The next expert group is on space debris. Next one is on space weather. The space weather was mentioned earlier on. And what sort of regulatory regime should we have in order to make sure all these three things happen? Now, I mentioned about the importance of the work of the committee. Now, this is the most important outcome of the committee, and that is the fact that the United Nations, all the member states, have agreed on 5 UN treaties and 5 sets of principles. Very important is that Outer Space Treaty. The second is the Rescue Agreement. This tells you if an astronaut from any country, for instance, lands on any place on Earth, what would be his rights. And we have an astronaut in our midst. They are what we consider the emissary of humankind. So they have a very special status within this rescue agreement. Liability convention, the word is obvious. Now, registration convention is how to register, and I have a little slide explaining that. And the Moon Agreement that tells you that despite what people tell you, people try to sell you, you cannot buy land on the moon. There is no way. You'd love to do that, I mean, and buying stars, you know, but no, you really can't do that. And of course, there are the declarations which I won't deal with. I mentioned about the register. Now, this is extremely important because this register is part of the transparency and confidence building exercise. We expect that any member state that launches an object into outer space should inform the world on the presence of that object and what it is doing. So the register actually contains information that member states give to us. So it's a unique instrument in the sense that it is an official information that the member states give to us. And if you are interested in this, go to our website and you'll see this register. It's a very nice instrument. I see so many young people here. You can tell maybe in the year 1967 who launched what satellites, who launched what objects. And if you're looking for India, you can look at India and see all the satellites that they have launched into space. And this is just an example of the registration information that is offered to us by member states. Now you'll be interested to see whether what are the recent registrations. So do go to our website and find out. Okay, so apart from space and diplomacy, space and law, we talk about space and development. I mentioned Unispace 3, and we adopted the Vienna Declaration, where, as I mentioned before, that we should protect the global environment, etc. But the most important outcome of UniSpace 3 is the establishment of this United Nations platform. This is a very long name, which is Space-Based Information for Disaster Management and Emergency Response, UN SPIDER. Another important outcome of it was the establishment of the International Committee on Global Navigation Satellite Systems, ICG, and I'll tell you a little bit more about it later. We talked about UniSpace 3, but that was 10 years, more than 12 years ago. Today, we are focusing on Rio Plus 20, which took place in Brazil last year, which is a conference talking about sustainable development. Now, COPOS contributed to it by raising awareness of the sustainable development community on the importance of space-derived geospatial data. Now, as the result of the work of COPOS member states, we actually managed to get a paragraph in the resolution or in the outcome document of Rio Plus 20, and this has never happened before. And the name of the document is The Future We Want. And there, in paragraph 274, it's right at the end of the report that the General Assembly recognizes the importance of space technology-based data. So this is where all of those plans which we saw, which the Israeli Space Agency is planning to put in space, will all contribute to the space technology-based data that we need in order to face the challenges of the world. So if you talk about Rio and Rio Plus 20, we talk about the Millennium Development Goals. But those goals will expire in 2015. And where do we go from there? As a result of this, the United Nations set up a task team on the post-2015 development agenda. And in realizing the future we want for all, my office has been very actively taking part in this. And there we managed to get space talked about in 2 paragraphs, one about the space environment and again about geospatial information. So we are very, very optimistic that in the coming documents dealing with development goals or sustainable development goals, there will be a reference to space. So let me very quickly talk to you about our office. We originated as a support system for the committee, and here you see a picture of, we started out in New York, but we are now in Vienna. Here are pictures of our lovely office in Vienna. We've been there since 1993. We are a small office, only 27 staff members, but from 21 member states, from 21 countries, and our expertise goes from aerospace engineering, astrophysics to space law. So we have quite a big expertise there, even though the number is small, and we have to bring the benefits of space to humankind, and through that, and for that, we promote international cooperation. There is the program on space applications. We conduct workshops, symposia, but please take note that the priority areas that we have is basic space technology, human space technology, and natural resource management. I say this because under basic space technology, we are promoting small satellite technology for developing countries, and human space technology focuses on bringing the developing countries to take part in the experiments that go on at the International Space Station. So this is about, as I said, bringing the capacity and the capability of developing countries to bring them one step further in space exploration as a global agenda. Ron mentioned this, that we have regional centers in various parts of the world. I won't mention this, but these are very important in terms of helping the office establish its capacity building in the whole world. Now, I particularly wanted to mention the International Committee on Global Navigation Satellite Systems, because within this international committee, of which the office is a secretariat, we are hoping to establish a system of systems of global navigation satellites. And we are hoping that there will be, through this international committee, interoperability and compatibility of all the systems of the world. There are, at the moment, not many member states which are members of the ICG, and maybe Israel could be one of them in the future. And so there are 4 working groups that you might really consider. One is a very, very technical working group which deals with compatibility and interoperability, led by US and Russia. The other is to enhance the performance of GNSS, especially for the end users. The third is to disseminate this information and do the training, which is led by USA. And the fourth is, again, a very technical group that talks about reference frames, timing and applications. And I really wanted to bring this to your attention because Israel could work within this context. The other is SPIDER. As I say, it's a mouthful, but I only talk about SPIDER. Here, we are not going on the ground to save people from disasters, but actually, we bring communities together. We bring the disaster management communities where the disaster happens with the space community. I see the capability, the Earth observation capability of Israel, and I did mention that you could, of course, offer these images in a disaster management context, and that would be one of your best contributions when you have your space infrastructure. So what are our future prospects? As an office, we will have to bring greater awareness of space tools for sustainable development, of course, and we need to ensure that there is greater understanding, acceptance of the UN treaties and conventions. Of course, you saw how big the UN system is. We have to make sure there is coherence and synergy within the system itself. And most importantly, we'd like to see greater involvement of the private sector within the UN work. This is not an easy concept within the United Nations. Member states are very conscious of their sovereignty within the work of the UN, and they do not want to be dictated to by private sector. But we believe that private sector has a very, very important role to play and must be part of the dialogue in the United Nations. And of course, we want to make sure that in exploring space in the future, in going to Mars and beyond, all member states of the world should take an active part in it. And if we had a group of human beings landing on Mars, and I'm told that within 30 years this could happen, this would be an international group representing the whole world, and hopefully not just one nation. So you've been a very attentive audience, and I'd like to thank you for listening to me. Thank you.
Thank you very much, Dr. Othman. מבחינתנו, מבחינת משרד...
As the Foreign Ministry is concerned, we very much encourage the Space Agency to become involved in this committee, which, as you understand, you saw the UN system and it looked a bit scary, but there is a world order, and the world order is determined in the UN, and that is where the regulations and the norms and their international conventions, and we also need to be part of that and to work according to those international norms and to do that on the ground by means of those committees. That's the place to do it, and it's also a good place to hear from other people and to learn from other people and to talk about our experience, and it's very possible that developing countries, and we very much need the connection, we need international legitimacy in our geopolitical situation. That is a good place to accrue international legitimacy, and I'm very happy that we will soon be joining. And that, of course, means that we need to be there, we need to send people, which we didn't do in the past. There simply wasn't enough money, not even one person we couldn't afford to send. So if we are bound to be part of that committee, then we have to be there. I'd like to thank everyone for listening. I'd like to thank our guests from Malaysia, Japan, and the UN. And I'd like to thank everyone for your attention. I would like to point out the very impressive presence of the students here and wish you all bon appetit.